Hey guys, this is Naveen here. Welcome back to Naveen AutomationLabs. So guys, today I'm going to talk about one of the most important chapter with respect to hash map, that how to make synchronized hash map. What is the difference between synchronized hash map as well as concurrent hash map, and what is the difference between hash table and the concurrent hash map, right? So we know that okay, by default Java hash map is not synchronized by default, right? Synchronized means at a time multiple threads can attack and can get the values and can write the values from the hash map object, right? And we really want the synchronized version of hash map. So there are three options are available. Either you can use hash table, you can use a synchronized map, or you can use concurrent hash map. So if you see in this particular diagram, I have taken this particular diagram from Google, and then you can see that this is a hash map object. In hash map object, let's see, this is the thread. Multiple threads can come, and it's not at all thread safe. It's not synchronized. Multiple threads, they can come. Let's see, this is T3, this is T4, T5, T6, and they can update the value, they can get the value, they can write the value, and we can have one null key and multiple values are allowed in hash map. But hash table is the synchronized one. It's a thread safe. So remember guys, this hash table is synchronized. Synchronized means if this particular thread is already working on this particular object, thread 2 is waiting outside. Okay, so it will provide a lock over here. So this is called a lock mechanism, right? If the thread 1 is working already, thread 2 is waiting outside. And once the thread 1 work is done, then only the thread 2 will come and then update and get the values over here. But we know that the difference between hash map and hash table is that thread safe. That's why if it is thread safe, thread is waiting outside, so obviously you will get the slow performance over here, right? But it does not allow any null key, and any null values are not allowed. Okay, so obviously if it is thread safe, one thread is waiting. Let's see, this thread is also waiting, this thread is also waiting, this thread is also waiting. So all these threads, they have to wait until this thread work is done. Now the thread number 2 is coming over here, then again it will be locked, so this guy cannot enter. This guy will enter once this work is done, and then this guy will come over here and then perform its work over there. So obviously that this is for the synchronized application where you don't need any concurrency. In that case, okay, only we have to use hash table. And guys, hash table introduced very long time back in JDK 1.2, and it's a legacy collection. And then hash map introduced in JDK 1.5, which is uh, are not a thread safe, right guys? It's not synchronized. Now the two important things, because with respect to hash map, we have synchronized hash map and one is concurrent hash map. And what exactly the difference between these two guys? A very famous interview question, and people 100% will ask you. Now see carefully. Synchronized map is another concept that is okay, just like concurrent hash map, but there are multiple differences. It means if you see this diagram carefully, the synchronized map will provide the lock. It just can see, and this is thread safe. Slow performance, obviously, at a time only one thread can work, and then it null key and multiple null values are allowed. But in a hash table, null key and null values are not allowed. That is the only difference. And then it will provide the log at the complete object level. It means this thread is working, then this thread is waiting outside. Same thing, this thread is also waiting outside, this thread is also waiting outside. So multiple threads in the concurrency environment, it will perform the poor performance. So that's why this is the another version of, you can say, hash table, including that it does allow all the null key and null values over there. Now, let's talk about one of the most important thing, that is concurrent hash map. This is again what exactly JDK, after JDK 1.5, they introduce a concurrent hash map. They say that okay, this is the complete object, and this object we know that okay, in hash map by default it will be divided into 16 segments over there. This is segment number 1, segment number 2, segment number 3, like that. So 0 to 15 segments will be there. It means 16 segments will be there. And then what is happening, there are two types of operation. One is the read operation and one is the write operation. So for write operation, for a particular segment only, the lock will be applied. So let's see, this thread T1 is coming over here, and this thread is trying to write something over here. So fine, for this particular segment, the lock will be applied, but let's see, one other thread T2 is there. So T2 can directly come to the different segment. It will come over here and then it will start writing something over here. So that is the good thing. It means at the segment level, the lock is applied, not on the entire object level. Remember this thing. And then while reading the value, there is no lock. Any multiple threads, they can come and get the values from the same thread, from the same segment, or from the multiple segment. So multiple reading threads are okay, absolutely allowed over here. No problem that okay, thread has to wait outside or something like this. So but for write, segment level lock will be applied. Remember this thing, not at the object level. That's why this is, we can say that okay, yeah, this is thread safe for the write operation and for the update operation for the on the specific segment. And that's where automatically the performance will be fast. Whenever you want to read something, multiple threads, they can come and they can read the value. But here if you see in hash table, if you really want to read something, you have to wait outside. Once the thread 1 is already read, then only thread number 2 will enter, and thread 3 and 4 in a particular queue it will come, and then it will one by one it will try to capture the value or write the value. But here we don't have any problem. In this particular environment, let's see, concurrency environment, 50,000 threads are there, and they are trying to attack this particular object or get the values from this particular object, and they are absolutely fine. There is no sync okay between them, right? So that's why we can say that it is completely thread safe. Yes, fast performance, null key and null values are not allowed, obviously. Just remember this thing. That's why they are the enhanced version of hash table, which is, you can see that okay, null key and null values are strictly not allowed, but with the fast performance, and it is also thread safe. So this is highly recommended according to Java documentation also. Which one you have to prefer? So hash table is also the synchronized version of hash map. Will you prefer hash table or will you prefer concurrent hash map? I will always go with concurrent hash map over here. Okay, so what exactly happens, guys? I'll give you quickly one basic overview also. Try to understand that. Let's see, I'll try to design one simple diagram about the concurrent hash map. So let's see, this is my concurrent hash map. It is, first segment will be divided into 0 to 16. So let's see, 1, 2, 3, then 12, 13, or something like this. Let's see, 0 to 15. So total number of 16 segments are available over here, right? And now what happens when we add the values over here? So let's say I'm adding some values over here. So the lock will be applied at the segment level. So this is segment number 1, this is segment number 2, like this, 0, 1, 2, 3. So by default, it will create 16 segments. You can increase the segment capacity also. That is also, you can do that. But by default, whenever you're creating the concurrent hash map, it will create 16 segments over here. But now let's see, this thread number T1 is there, and thread number T2 is also there, thread number T3 is there, and thread number T4 is there. They want to write something in this particular concurrent hash map. So what exactly, how exactly they will do that? This segment is occupied by T1. So T1 is writing, let's say 100 over here. Then T2 is also wants to enter. So T2 cannot come over here, guys, because this segment is locked now. Because the segment is locked by T1. So at the write level, whenever we are doing any write operation or any update operation, the lock will be applied. So obviously that is needed. Otherwise, what will happen? T1 is updating and T2 is also updating at the same time, right? But T2 cannot come over here in this particular segment. T2 can come in some other segments over here like that, and it will may enter 200 over here. So T2 either can come over here or can come over here. Same thing, T3 can come other segment, T4 can come in this particular segment and entering the value, let's say 300 or 400, like that. So what is happening whenever you have to update or whenever you have to add multiple values in your hash map? In that case, concurrent hash map is very useful over here. So concurrent hash map, right? Like this. Now let's see, there are other threads. Let's see, T5, T6, thread number T7, and thread number T8. Now all these four threads, they want to read the value. So what is happening? Let's see, this thread number T5 can come over here and get the value 300. Thread number T6 will come over here and read the value by using the get method and then get the value over here. Same T7 can come over here and can get the value 400 also, right? Let's see, the value is available MacBook. Talk about Amazon. One string is available over here. And there are 10,000 people during the Thanksgiving day. It means 10,000 threads are available. They want to access the same value. So they all can come and get all these values and everybody will get the MacBook over. There is no lock operation is applied over here. But in HashTable, lock is applied. It means obviously you can think about for e-commerce application, which one you prefer, Concurrent Hashmap or HashTable. Obviously, we will go with Concurrent Hashmap where 50,000 users or 10,000 users, they are trying to access, they are trying to search MacBook. So in my search algorithm, I'll be applying my, for getting the value or for the product information or something like this, I'll be maintaining one Concurrent Hashmap instead of synchronized map or hash table over here. Got it? So whenever we want to make a hash map, it's a synchronized version, guys. In that case, I will always go with the concurrent hash map because concurrent hash map will provide the lock at the segment level. So these are called my segment. Okay. So let's talk about once again the hash table. So in hash table, guys, what happens? Let me just show you once again with respect to hash table. So let's see. This is my hash table. Again, it is divided into 16 segments, started from 0 to 15, and multiple segments it is being divided. The problem with this, if this particular thread T1 is coming and adding the value, let's see 100 over here, but T2 also at the same time and T3 also at the same time, they want to add the value, they cannot. So it has to wait. So they will, and then the wait condition will be applied and the waiting mechanism will be applied over here. Like once the T1 is done, then only T2 will enter into this particular object. And then accordingly, T3 will enter into the object one by one. They cannot access the object at the same time. So that's why we are doing a write operation over here. So it is a synchronized. Remember this thing. So hash table is always synchronized. And let's see, there are 10,000 users are there. 10,000 users means 10,000 threads are there. In this case, what will happen? 10,000 threads means all these threads, they want to try to get the value that, okay, let's see, MacBook is written over here. And then Nike good shoes written over here, like that. So what will happen? All these threads, they will try to access these values one by one. First this guy, then 10,000 times. So now what is happening here? It means 50,000 users or 10,000 users, they are trying to access the value one by one. So in that case, you will get the poor performance over here or slow performance over here. So remember, this is the problem with the hash table. But here we have talked about this a concurrent hash map, which is the best suitable thing for the concurrent environment. In that case, if you really want to write, fine, you will get a lock over here, but another thread they can write in some other segment because other segments are free. Only this particular segment is locked whenever T1 is performing some writing operation over there. Now you can ask one thing that, okay, let's see, Naveen, that one 10th thread is there, which is updating one segment over here, 100, and this T11, another thread is also reading the value over here. So yes, what will happen? And let's see, T12 is also adding the value, right? So once T10 is free, T12 is adding 200, and then T1, T11 is coming. T11 will always get the latest value. So this guy will get the latest value as 200. So this is also available in concurrent hash map. The latest value, okay, the latest updated value will be picked. So whatever the latest updated value, by the time that T1, T11 is entering over here, by the time T12 has already updated this 200. So this guy will get 200 over here, not the 100 one. So that's why for the write operation, it is amazingly good. And for the read operation also in concurrency environment, absolutely you can use that. Okay, so remember this thing, guys. This is the difference between, remember this diagram, hash map, hash table, synchronized map, and the concurrent hash map. And in concurrent hash map, you can say fast performance, null key, and null values are strictly not allowed. So which is obviously a much better version as compared to hash table. And concurrent hash map came in JDK 1.5, and hash table is a legacy, and generally we don't use in real-time applications. Perfect. So let's see the basic implementation of how to write the code and everything for concurrent hash map and synchronized hash map. So I quickly come over here, and you can simply use a synchronized map over here. Okay, you can write synchronized map method in collections class. You can use that, okay, for the implementation of, the synchronized map. So how to do that? Let's say I'm going to create a map over here. Let's see, a simple map which is holding a string comma string, and let's say this is my map 1 is equal to new hash map that I have to create first, and then string comma string I'll be writing over here. Import these two guys, and then guys I'm adding, let's see, some values over here. That is, let's see, map1 dot put method, and I'm adding, let's see, my first key, something is returned. Let's see, Naveen is written over here, and then I'll add two more values, number 2 and number 3. So I'm talking about the synchronized map. I'm talking about this synchronized map. Okay, and hash map we've already seen in the previous videos so many times, right? And let's see, here I'm writing Tom, and here I'm writing Lee. Now I want to create this hash map into a synchronized map, because hash map by default is not thread safe. I want to make it a thread safe with synchronized map. So this is an interview question. So how will you do that? So I'm going to create one synchronized map. So I simply write, let's see, create synchronized map now. So what will you do? Use this particular class collections dot synchronized map is available. Can you see that? And pass your map. What is your map? Map 1. And this will return one synchronized hash map, guys. So obviously we will store in some a different map reference over here. Let's see, map number 2. So this is my synchronized map. I give a better name, synchronized map. And then you really want to print this particular synchronized map. I simply print it. Let's see, sync. So here you're getting Naveen, Tom, Lisa. Simple. So remember this particular method name. How will you convert your synchronized map, hash map, into a synchronized map? You have to use collections.synchronized map method. How to create one concurrent hash map? So concurrent hash map, which is a class which is already available in Java. So how to use that? So you just need to create the object of concurrent hash map. So now we will talk about concurrent hash map. Okay, so let's simple write concurrent hash map, and what kind of keys and values you want. So let's see, I'm using a string comma string. You can create any kind of key, and let's see, this is my and then in this particular concurrent map I'm going to add multiple values. Let's see, dot put, and then I'm adding on the a key, the value is Java. Okay, and then I'm going to print, I want to get some value. Let's see, system.out.println. I simply write concurrent map dot get, give me the value of what exactly the value is available on a key. So you should get, let's see, Java over here. So in concurrent hash map, guys, whenever you are trying to add multiple values in the multi-threading environment, what you can do is that, or maybe I can show you later, that you can create one multi-threading. You can create the pool of 5 threads of multiple threads using multi-threading, and you can extend this particular class with a thread class, and then try to create multi-threads, and then try to keep adding the values. You will never get the concurrent modification exception over there, but in case of synchronized map, you will always get that particular exception. Okay, so the exception name is concurrent hash map does not throw any concurrent modification exception. Okay, so it does not throw any, remember this is also interview question, that concurrent, this is a very famous exception in Java collections, that if you try to update the value, okay, if you try to modify the value by the another thread, okay, so in that case you will get concurrent modification here. But here in concurrent hash map, just because of the mechanism is so unique, the lock will be applied at the segment layer, and then if you try to add one more value by using another thread, you will not get any concurrent modification exception over there. Okay, so this is the difference between all these 4 guys. So please, very important interview question. If you're going for any product companies, or if you are a fresher also in your college placement also, if you're interested in Java and you're saying that, okay, yeah, I'm good in Java collections, and people will ask you. So please use these kind of techniques to explain at a time of interview, and practical example also, you can see that, okay, the way I've given that, what kind of application you will be using it. So yes, okay. So so HashTable is a legacy. Now there are let's see, let me ask some basic interview questions over here that can multiple thread write in the same segment in concurrent hash map? It is not allowed, but in the current complete map, it is allowed. Now another thread can come over here and can add the values over here. So that's why we will never get concurrent modification exception over here. Now the next question is that can two threads write in the different segment? Of course, we can do that. Two threads are allowed to write concurrently in different segments. This guy can write over here and this guy can write over here. Another thread can write over here. Absolutely allowed. Third question is that can multiple thread read from the same segment? Yes, of course, because there is no lock whenever we are doing a get operation, or whenever get means the read operation. So there is no lock. Multiple threads can definitely come and can read from the same segment. Yes, we can do that. So that's why the performance will be increased while doing the write operation. Then the next question is that if one thread is writing in a segment, can another thread read from the same segment? That is what I told you, that one thread is writing in the same segment and another thread reading from the same segment. So T1 is writing over here and T11 is getting the value, reading the value from here. So yes, in this case, the last updated value, the latest updated value will be seen by the reading thread. So whatever the reading thread is there, so this is my reading thread, means it's performing the get operation, and this guy is performing the put operation, means write operation. So the latest value will, so null keys and null values are allowed in concurrent hash map. Concurrent hash map does not allow any null key and null values. If you try to add, you will get null pointer exception. Perfect, guys. So these are the important discussions, important points that I have told you. Please prepare this question. People will ask this question 100%, and most of the people, they get confused between these four guys. So thank you so much for watching this particular video, and if you really like it and if you really want to add some more points about these four collections, please feel free to do that. Till then, take care, bye bye, and please subscribe to the channel. If you haven't subscribed it, press the bell icon to get the notification for the next video. A lot of interesting videos are coming soon, guys, and till then, take care, bye bye.